Hello, this is Dr. Arberg, and our presentation today is Business Development in Mechatronics. We will take a look at the three indicators of next-generation mechatronic growth, suggested strategic direction in mechatronics business development, and the tactical steps in getting started. The trend in business development of AI opportunities is shown over here. It is expected that $50 trillion will be invested in AI business development, 15 trillion in the next decade, 0.8 million new jobs by 2021. So it makes sense that to get on board the AI business development wave, we will start with mechatronics. The mechatronics indicator number 2 shows that the non-tangible AI assets, which are patents, are increasing exponentially with AI and machine learning. We see that in this graph. Now, it makes sense to patent our AI inventions because patents increase the price-to-book ratio of the business that we try to develop. The price is what the investors are willing to pay for the business. The book is the net present value of all future tangible assets. To determine the net present value, we have to start with the three business development financial statements. One is profit and loss. Add to it the investment, and we get the cash flow. Add to it the tangible assets, and we get the net worth. The net present value of the net worth after so many years gives us the book value. And let's take a look what the price to book values of different type of companies. We see over here banking companies in 2015-6 is between 0.5 to 1.5. The investors are willing to pay no more than half the book value, up to 1.5. The reason is that banking have lower risk and very low non-tangible like patents assets. Take a look at the automotive industry. Over here we see higher price to book ratio, 1 to 3. And the reason is because there is medium risk taken by the automotive industry with medium non-tangible patent assets. Now, when you look at the Microsoft, Google, Facebook, Citrix, at the same time, you see that the price to book is between 3 to 7, almost an order of magnitude higher. And the reason is because there's a much higher risk in the new technology with a lot of non-tangible assets, which are the patents. The third indicator says that to stay close where the big business development investment in AI go, it will make sense that the business development that we try to do in mechatronics will be in the same direction, which is today cognitive manufacturing. Cognitive manufacturing is defined as the transformation of manufacturing in three focused ways: intelligent, assets, and equipments, utilizing connected sensors, analytics, and cognitive capabilities to sense, communicate, and self-diagnose issues in order to optimize performance and reduce unnecessary downtime. So we would suggest to add AI features to your mechatronic products with these objectives: minimize equipment time, downtime, and maximize equipment throughput. Now, the conclusion is that artificial intelligence is a natural extension of mechatronics in industry today. Mechatronics already has large number of equipment, industrial automation equipment. The industrial automation equipment already have mechanical, electrical, communication component on boards. We see positioning stage, conveyor belts, indexing table. These are actuators. These are all mechatronics equipment which are ready and equipped to be upgraded with artificial intelligence, machine learning components. And also the cost performance of improved values, such as increased throughput and reduced downtime as needed for business development planning, have an existing method to be estimated. As an example, saving 1 hour downtime in automotive industry is known to have a value of over 100,000 K. So a suggestion common sense strategies in AI mechatronics business development is number one, add AI machine language features to your existing or new mechatronic products. Think big, meaning think of multiplicity. Choose products that sell in high value and that you may join them in order to collect multiple machine learning data with them. Start small with a demonstrator, set up a lab environment for demonstrating the new AI machine learning technology, get technology support from one of the big AI machine learning service providers such as IBM, Microsoft, Google, and Amazon. Move fast if you like to be recognized as a leader in a mechatronics artificial intelligence supply chain. And also protect yourself with AI machine learning process with provisional patent coverage. The suggested typical tactical approach to get started is to step one is identify the details of your machine, identify performance variables that affect throughput, for example, RPM, acceleration, dwell time, or settling time. Identify disturbance variables that may affect downtime. For example, vibration, temperature, and force may cause failure. Precision, following errors may cause performance slowdown. Also identify commercial wireless sensors with signal conditionings that will measure these variables in real time. For example, accelerometers, load cells, pressure sensor, thermometers, cameras, ultrasonic proximity sensors. And then the final example that we like to show is step two in the tactical motion is to develop a mechatronics system and a model. So we already have here, we see in this example, we have a host computer that communicates through the Ethernet to some measuring devices and also to the PLC and the motion controllers over the Ethernet. And then the motion controller connects to the amplifiers through some field bus such as the EtherCAT. And the system delivers through cable management power from the amplifier to the motors in order to do the job. This, for example, shows a patent by Goodyear for the next generation tire winding with filaments. And the tire here is rotating at a certain RPM, and the XY Parker motion with a applicator is winding the filament on the tire. Now, how would we improve that with AI machine learning devices? The example here calls for an LCD sensor placed over here that measures vibration and temperature. Then developing in a cloud an AI machine learning model, for example, that the vibration equal to some parameter A plus another parameter B times the value of the temperature plus another parameter C times the value of the RPM. And then once we have that, the model is going to collect the data. It's going to be streamed into the cloud through the internet and update the parameters ABC such that we get the best regression between the vibration and the temperature and the RPM. Once we have that, then we can state in a program that we feed into the cloud that if the vibration is greater than the maximum allowable vibration, then reduce the RPM. And if the temperature is greater than the maximum allowable temperature, then stop. So the machine learning is going to be automatically updating these variables when the information is coming in through the wireless connection into the hub. And the machine learning is going to provide to the host computer statistics about this operation, as well as command the PLC to do the program, the instructions, such as reducing RPM and stopping. This pretty much completes our presentation with this example, and we'll see it again when we talk about the exercise of this course. Thank you.